Hi, I'm going to show you how to do the calculations for the heat effects and calorimetry lab experiment. Sorry, I dropped my paper. Okay, so we're following these directions. I even numbered them for you, just so you know when you come into lab. I've already done step 1 for you. I got the hot water bath going for you because time is limited this week because of homecoming. We're going to start at step 2. So you just have to be patient with me. I've already filled in these numbers. Step 2, weigh your sample of unknown metal. This includes the stopper and the test tube. Everything. I got 113.65. Then it says step 3, weigh the empty test tube and stopper. So I just dumped the metal out and I weighed that and I got 75.27. Now in step 4, it says to replace the metal in the test tube and put the loosely stoppered test tube into the hot water in the beaker. In other words, your metal needs to be submerged in the water. We're going to heat your metal up in this hot water bath. You're going to heat for 10 minutes. 10 minutes. And your water should be boiling. While the water is boiling, we can go on to the next step. The mass of the calorimeter. This is without the lid. This is without the stir. This is without the thermometer, okay? This is just the inner and outer calorimeter. I got 20.57. Now, we added, it says in the next step, to place about 40 milliliters of water in the calorimeter and weigh again. So I place 40 mils and I get 60.57. Yours may be different. You may not be exactly 40. If you're not, that's okay. Subtract these two and you have the mass of your water. You also need to get the mass of your metal. While this metal is heating in the hot water bath, you can be doing all these calculations. The mass of the metal, isn't that going to be the difference between these two? This is the stopper, the test tube, the metal. This is the stopper and test tube. You subtract them, you get the difference, the mass of the metal. We also, at this time, while we're waiting on our boiling, is to get the initial temperature of the water in the calorimeter. I got 25 degrees Celsius. Now, take a look. This is where it's going to be hot. 10 minutes have passed. You are going to take the test tube out of the beaker of boiling water, remove the stopper, and pour the metal into the water into the calorimeter. You're going to have to do it quickly. You're going to dump the contents of the metal in there. That's it. No stopper, no test tube go in there. Carefully place the lid back on your calorimeter and stir it. When the temperature has stopped moving in your water, then you're going to have a temperature to record. So here's some things that we know. The initial temperature of our water, well, it was in a hot water bath. It was boiling. The metal took the temperature of the boiling water, 100 degrees Celsius. The temperature after the metal was put into the cold water, 35 degrees Celsius. Here come the calculations. You need the change in temperature of the water. That's the final temperature, the equilibrium minus the initial. I got this right here. Do the same for your metal. Remember, your metal is the same temperature as that cold water now, 35 degrees Celsius. So 35 minus 100, negative 65. Yes, you're supposed to get negative because it's losing heat energy. The next calculation, Q of water, well, that's that calorimetry equation we talked about. M times C times the change in temperature. This is the heat of the water, so we need the mass of the water, the specific heat of the water.
And Galen Maxwell, report to the front office.
Sorry about that. And the change in temperature of the water, which we already got up there. So 40 times 4.18 times 10 gives me 1672. This is how many joules of heat energy our water absorbed. This next line, we're not going to do equation 3. I find that there's actually probably a better way. So I'm going to go to notebook paper. Bear with me. Did you know that the heat that the water absorbed is equal to the heat that the metal lost? Think about it. It's in a calorimeter. It's a completely closed system. They're the same. So we're going to take the Q of the metal equation, the mass of the metal, times C, which is unknown. That's what we're solving for, and the change in temperature. I know that these two are equal, so this is going to be negative 1672. Oh, sorry, positive 1672. It lost it, but we're going to make this positive. I see what's going on. Okay, so yeah, this is negative. Sorry. If this gained it, this lost it. Negative 1672 times the mass of the metal. Well, I go back to my data. The mass of my metal was 38.38. Times C, which I don't know what it is. The change in temperature was 35 minus 100. All right, let's simplify this. 35 minus 100 is negative 65 times 38.38. So I get negative 2494.7 times C. We worked one of these on our first day of learning to practice these. To solve for C, divide both sides by negative 2494.7. Negative 1672 divided by negative 2494.7 comes out to be 0.67. This is our specific heat. It's in joules per gram degrees Celsius. That's what you put right here, 0.67. Do not worry about the unknown number. Everybody's got the same one. The approximate molar mass, I do believe that was equation 4. We can handle that. The molar mass is 25 divided by the specific heat, 0.67. I get 37.31. That's the molar mass of our metal. Now, I made up these numbers. I don't think that this molar mass fits anything on our periodic table. Yours will. You do have a specific element on the periodic table that will help you, that this molar mass will help you identify what it is. Okay, if you want to, you can put it right there. I hope this has helped you to understand how to do the calculations. If not, you can replay me, or excuse me, you can have me come check your math and point you in the right direction. Thank you very much for listening. See you later. Bye.